Oh. We're going to go over lab 2, which I'm calling keypad mid-level primitives. So we started off at this high level, double in, and then we're kind of going down, drilling down into the hierarchy a little bit. So I'm going to write just one function this week. I give you one, write one. But it's kind of I would say this is a little bit of a trickier function, the one function that you're writing this week, than last week's functions. But you don't really need anything drastically new. So there's not as much guidance this week because last week there was like everything was new, and this week there's not as much new. So we're going to try to gain experience with code requirements for character input-output of custom embedded computing application, and then online debugging techniques. So in exercise 1, we implemented a general purpose function double in that prompts the user to enter a floating point value on the keypad and returns the result to the calling program. The function calls the C functions printf LCD and fgets keypad. These functions, in turn, call other lower level C library functions according to the following hierarchy. Functions provided in this hierarchy by the ME477 core C or the standard C library will be overwritten by those we write, which are shown in green. So I showed the hierarchy a little bit fuller this time, a little bit more detail. And I included the bold green ones are the ones that we write. And actually, I mean, like we're writing fgets keypad. We can write fgets keypad when I gave you the code for it. We could just use the library one. We don't have to pretend like we wrote it either in the report. So, but these are the two in this lab. This one's going to be given to you, fgets keypad, and then getChar keypad. We used fgets keypad, of course, in our lab 1. We used it when we wrote our double in function. So we kind of know how fgets keypad works because we had to understand how to use it. Remember, what we do is we give it a string, a character array, and it writes to it, right? So we're going to actually like unpack how it does that. We're going to go through that in a moment. And then we're going to write the lower level functionality, which is actually a little bit more interesting, I think, how getChar keypad works. And then next week, we'll do getKey and putChar LCD, which is used in in getChar keypad, and it's used in printf LCD. And then we'll be done with the input-output with the keypad LCD interface. It'll be written, and then we can just start using it for the rest of the term. And then I mentioned some other important functions that we can use. And last week we used these three, right? scanf, string, and
VSM print also.
yeah, we also use this one too.
This one I
That's right.
don't really understand why we have to have and.
As I recall, it was essentially formatting the string, right?
Yes, just to verify it is the correct one.
Yeah, so I think that one's used at this level too. But it's also used in, we wrote printf LCD, so it wasn't at that level. We wrote, this was last week too,
Yes.
so VSM printf. Yeah. And we used putChar LCD last week, but we didn't write it.
Yes.
So we will eventually write it, which will be next week. Okay. Continuing down the hierarchy, fgets keypad gets a string from the keypad. Due to time constraints, we will not write it ourselves. Instead, we will use the ME477 library version. But for reference and understanding, its source code is displayed in the following listing. So we knew that this was the prototype for fgets keypad. You handed a character array and then the length. And then what it does is it says, okay, it assigns a pointer to the buffer. And then the buffer end, it defines as a pointer to the last address. So what it does is it says, okay, the buffer, the first address plus the last address, or plus the length of it minus 1 is the last address. So we know, so we can test to see if we've reached the last address in the buffer.
So when we write it like this, buff and equal to assigned to buff plus buff length, because buff length is an integer like the number.
Right.
But the buff here is string.
It's a pointer, yeah. So it's a pointer to the first character in a string. And so what it does when you increment a pointer, it's smart, and it knows to go to the number of pieces of data. So it goes buff length pieces of data forward, and then a minus 1 backs it up 1. So you find the pointer to the last piece of the character array. So what you're going to use that for is to test to see if you've reached the end of your buffer.
Yeah. So when we write just write if buff is a pointer, when we write buff, it is the first address, the first.
Yeah.
First element.
Exactly. So yeah. So you could say buff, or you could say buff of 0.
Yeah.
It's the same. Yeah. So actually, I should say buff. You could write buff dereferenced, or you could write buff of 0.
So buff n points to the last index of buff?
Yes. So the buff end is a pointer to the last index. So and remember that pointers are just so addresses are just integers, right? So you can compare them in size. So you can say if pointer is less than buff n, which would mean if your pointer that you're going to be incrementing as you go through this loop, if your pointer hasn't reached the last pointer position yet, so that gives you a nice exit condition for your while loop. What's interesting about this while loop is that we don't expect that it's going to exit based on the while condition here. So we're saying, worst case, we fill up the buffer completely. But we don't expect that that's our normal case. But once we do fill up the buffer, we are going to exit. We're going to have another exit condition that we're going to expect is the sort of standard case of exiting the loop. And so what this next line is it's going to get a single character from the keypad using this getChar keypad, which we're going to write today. But it goes down and it gets us one character, and notice it's not writing it to a string or a character array that we're handing it. It's returning the character, one character at a time. And so we get that character, we assign that character to C, and then we're going to check to see if that's an end of file, it's an EOF character. If it is, that will break our loop. Okay, so we're going to stay in this loop until we either reach the end of the buffer or we reach an end of file character. And if it does reach it, we'll break. If it's not, we got this C. We're going to write this C value to, and remember when we were talking about writing to the value of an address, this is exactly what this is doing. And we're going to talk more about this at the end today. This is exactly what this is doing. It's dereferencing P. It's saying, okay, pointer, dereference it to the value, and then it's going to say that value, let it be equal to C. So put that character there at that location, which that pointer, remember, is going to be pointed the first time through to the first character in the buffer, and in the character array buff, and then we're going to increment P. So that's the next step. So each time through, it goes to the next pointer, but it doesn't do that till it's assigned C to that value, which is exactly what we want. And then it goes back through the loop until it either reaches EOF, so it keeps putting characters in the buffer until it reaches EOF or it reaches the end of the buffer.
What question about what is the starting value of P? Remember? Yeah. P equal to buff, it is 0.
Right, so what we're gonna do is we're gonna leave buff alone. We're not gonna change the buff pointer at all. We're gonna use our a buffer pointer that we're gonna move along the buffer. So if the buffer is like all these addresses, P is gonna start out pointing to here, and so is buff, right? Buff also points to the first one. But then we're going to increment P, so P is then going to move over to here. This is the plus plus. And then it's going to be plus plus again, plus plus. So that's going to point to the next one. So we're going to keep moving the P pointer along until we reach the end of the buffer, so either until we reach the end, or until getChar keypad doesn't give us any more. If we ask for another one from getChar keypad and it gives us end of file, then we know that getChar keypad's done. The keypad entry is finished. So, yeah, does that make sense?
Yes, because when we give, for example, buff is, we put string as a in place of buff. So the starting point of this one must be as the value. Because the way we use get keypad, we put one variable in there, and then the length of the array.
Right. So, and this is actually the same. This is the same character array because fgets keypad is handed that. We said fgets keypad. And then the argument that we put into it was, we called it string, right? It was a variable that we called string, and then we said 40 or whatever it was. And that was the string, the character array that was called string is what fgets keypad wrote to, right? It filled this up. So this is in memory up at the higher level. It's not called string inside this, but at the higher level, when we used it in our double in, we called this thing string. It's called buff inside this. We could have called it anything. We could have called it string also, right? We called it buff, but it's exactly the same memory addresses. It's exactly the same character array.
So each time when it call, you need to type, and this typing will go to this array. And the first typing number will go into the first element of the buff.
Yeah, well, and actually, so what we're going to see is that getChar keypad's going to add another buffer to this thing so that you can edit. So if we did an unbuffered getChar keypad, each character that became available, getChar keypad would just send right up the line to fgets keypad, and C would see it and would write it into the buffer. But then we can't do editing. Well, we want to be able to do editing. We want to be able to hit like backspace, right? And if we want to hit backspace and delete, we need to buffer it before we write to our buffer that's going to get read up there. We want to buffer at a lower level. So we're going to, this buffer here is the buffer that double in deals with, and this is the buffer that fgets keypad deals with. But getChar keypad is going to have its own little buffer it's going to take care of it. And it's going to be a totally separate buffer. But that's the buffer that's going to let us do the editing. So that's what we're going to write this week, is that lower level buffer. It's pretty fun. I have this whole analogy I'm going to use with islands and a guy in like a canoe or a kayak or something who can only carry one character at a time back and forth. Yeah, it's going to be fun. Something to look forward to. Okay, so after this while loop ends, which means that the buffer has been filled, right? Buff has been filled. Then if P is equal to buffer, meaning that P never moved, right? So the very first character had to be end of file, that means that just enter was entered, right? That means there's nothing was written to the, nothing needs to be written to the buffer because the very first value that came through was enter. That's the case where you run it and then you just hit enter. You don't hit enter anything. Remember that fgets keypad is supposed to return null in that case. That's what we set up at double in. We were expecting it to return null and not write to string at all. So that's what this is doing, which is good. I mean, this is what we were assuming that fgets keypad was doing last week. So this week, fortunately, that's what we're doing. So
What is the difference between end of file and the null?
they're different symbols. So null is a specific symbol. End of file is it's supposed to be put at the end of every file, and then you can use it when you have like a string if you want to say like this is the last one. You can use it there too.
But it's the same as null. In some circumstances, we can use it.
In certain senses, it's the same. Yeah, but we just have to recognize that it's going to be looking for end of file. When we write our get char keypad, we have to stick in an end of file at that level, so that it returns end of file when we get to the end of the get char keypad buffer.
So end of file doesn't equal to enter. You mean in this case?
End of file is what we're going to translate enter into at the lower level. At the lower level, we're going to say, oh, enter was hidden. We'll put in an end of file character there. So then, if p is equal to buff, that means that we return null. Otherwise, so return actually exits this, right? So it doesn't go on. But if it's not, meaning that there is something that was written to the buffer, then we put as the last character null. This is another way to write null. If you write it as a string literal, then you can write the /0 \0.
But it's an integer in this case.
So no. So this is interpreted to be identical to null.
And that's /0, not /0.
That's /0, yeah, /0. And as a string literal. And then we return not the. We don't return null. We don't return anything else. What we return is buffer, which is to say the pointer to the beginning of the buffer. So which is what we were handed. So that's the return value. So yeah, it's the address of the first of character in the string. So this function gets one keypad character at a time from the buffered get char keypad and writes them to the character array buff via the pointer provided as an argument of the function. In this lab exercise, you will write the lower level get char keypad function. This function acquires a single character from the keypad. It must function identically to the standard C function get char that performs the same operations for the standard I/O device, the console. So this is how it C interfaces with your stand or just your keyboard also. It has a very similar function called get char. Our get char keypad should function just like that. You should review the get char function in your C textbook. So like Kernahan and Ritchie talk about get char quite a bit. In lab exercise 3 next week, you will write the lowest level I/O functions get key and put char LCD. Pre-lab preparation. So here are sort of the descriptions of how to write these. How to write this, really only the one. So write the following functions and compile and debug them before running them while connected to lab hardware. Of course, we're a little lax on that because we have quite a bit of availability on the lab hardware. So writing the buffered function get char keypad. The prototype is that you hand in void, which means no arguments. So it's not accepting any arguments. And each time getChar keypad is called, it returns a single character from the keypad. Notice it returns an int and not a char. And the reason for that is that we want to be able to return ints. So chars are stored as ints, right? But just a subset of ints. We want to be able to return some characters like end of file that are not standard ASCII characters. So we say it's an int so that we can also return an end of file, which is fine. So it works as an int, but it wouldn't work as a char. So that's a little why. That's why we don't return a char instead of we return an int instead. So yeah, it returns end of file defined in the standard IO when it encounters its representation of enter. In the example below, getChar keypad is used to obtain a string of characters until end of file is reached. The characters are stored sequentially in a buffer pointed to by the pointer named point. So this little snippet here is while, and so this is another one of those sort of compound C strange ways of writing something, where we call getChar keypad, which returns an int, right? A character that's encoded into an int, assigns it to ch, the variable ch. Then it compares this value to EOF. And if it's not equal, so as long as it's not equal to EOF, it assigns whatever that is to the place in memory that point is pointing, and then it increments the pointer until it reaches an end of file character, in which case it exits the loop.
Which in our case is enter,
right? Which means enter in our case. So this little snippet is the type of snippet you would want to see in your getChar. Or this is the type of snippet that we saw, I guess, up here. Essentially, it's this line here, and I mean, what we did is we did a while for the buff end, and then we did it C equals EOF. So it's essentially the same logic. What was your question, Dan?
Yeah, why does not equal have like a higher priority over equal? It's like I was reading the book.
Yeah.
You put parentheses signs when you're doing that, because otherwise it'll say basically.
Right. It'll group these two.
Yeah, it'll group the whole thing.
It'll group these two together,
Yeah.
and it'll compare them and then assign it.
Yeah.
Why? I don't know if I could answer why. They had to choose some order. I mean, for me, when there's an equal sign, an assignment operator, an equals, like for me, that should be the higher priority, except for parentheses, I guess. Like you could explicitly group things with parentheses. But I've noticed that in C, they really like to mix assignments as part of statements. And so I guess for them, like it felt more natural. A lot of it comes down to what is the most intuitive. And then they set it, and then they could never change it. So, yeah, for whatever reason they chose that. I don't know why. And for me, I will sometimes look back at the reference, like the table. So there's a resource in Appendix C that has the order of priority of the operators. Sometimes I'll look back to that, or sometimes, honestly, I'll just put parentheses if I'm not sure, or I'll just try it and see which it is, because I don't know. So I'll test it and see which one it is. But you could also look it up in the table to see which one will be associated. Sometimes it gets subtle when you got like 3 different terms, and then you've got the different groupings, like which one happens first. So what does that? Interpreting what a statement means in C is much harder than in a lot of languages. Some people think that's a feature, though, so I don't know. Okay. So there are two types of getChar functions in C. The first type is called an unbuffered getChar, which simply returns the character to the calling program immediately after each keystroke. The second type is called a buffered getChar, which collects the characters entered by the user in a temporary buffer. Pressing enter causes the block of characters to be made available to the calling program. You will write a buffered getChar keypad for the keypad. So the advantage of buffered getChar is that the user can edit the characters in the buffer using the backspace key in the usual manner before they are sent to the calling program. There's no possibility of editing with the unbuffered getChar. You might wonder how a function designed to return only a single character could edit the whole buffer. This is accomplished by a simple and elegant means inside getChar keypad. The idea is to use a statically declared character buffer. In this way, the characters remain in the buffer in between calls to getChar keypad. You will also need to statically declare a pointer to the buffer and a variable, for example, n, to keep count of the number of characters in the buffer. A schematic of the buffer, pointer, and count variable is shown below. So here's your buffer, and this is inside getChar keypad. So this is not visible at all to fgets keypad, the level above. This is down in there, and it never gets exposed in its entirety. The only thing so the fgets keypad never knows about this buffer. All it does is it asks for a character, one character at a time, and getChar keypad sits there and goes, okay, wait, okay, I have a character. And then fgets keypad has to ask, do you have another character? And it says, oh yeah, I have another character. And then it asks, do you have another character? Yeah, I have another character. Do you have another character? This is end of file character, meaning I'm out.
You use it.
Yeah, so now go off and do your own thing. So it gets one at a time, but it does so, and it knows, it has like a sort of, there's a signal that it has with getChar keypad, like, oh, okay, now you're done because you gave me end of file. So that's how the buffer down at the getChar keypad level is working. So here's how the buffering scheme should work. Whenever getChar keypad is called, either the buffer is empty or the buffer contains one or more characters. So we're either in this state where we haven't done anything with the buffer, we haven't filled the buffer at all yet, or we've filled the buffer and returned the first character, and this is another call to it asking for another character. So we're either in one of those two situations. So the first time getChar keypad is called, the buffer is empty, the count is 0, and the pointer is at the beginning of the buffer. The function enters a loop. This is the result of what it should do. Function enters a loop, filling the buffer and displaying the characters one keystroke at a time until the enter key is pressed. So we don't want the user to like type in the keys and not see them all until they hit enter, right? So every time they hit a key, they should see it on the LCD. So you got to do putChar LCD just to make sure that it's printing each time they hit a button, but keeping them in the buffer, not releasing them up to fgets keypad yet. We're not ready. Fgets keypad needs to wait while it gets all these keys, and then it says, okay, I've got my buffer, I've got my enter, and now I'll start feeding them one at a time back up to my fgets keypad, and that means that it's now ready. Like now it's released. The editing's done. Enter was hit, so we don't need to worry about editing anymore. I can feed them up, but it only spoon feeds one at a time. Okay. Good. Each time through the loop, it checks if the buffer is full. If it's not, it completes the following tasks. Enter the current character into the buffer at the pointer's pointee. So pointee is the position that the pointer points. 2, increment the pointer. 3, increment the character count. And 4, print the character to the LCD. So that's what it does. After enter is pressed, the buffer pointer is set back to the beginning of the buffer, and the first character alone is returned to the calling program. On subsequent calls, getChar keypad to getChar keypad. The buffer is not empty, right? So now it's ready to start releasing these characters. For each call, the pointer is incremented, the count is decremented, and the character pointed to is returned to the calling program. This continues until the last character in the buffer is returned, and the pointer is returned to the beginning of the buffer. Once the buffer is empty, the next call to getChar keypad begins the filling process again. So we're ready to start over again, new buffering, entering keys.
Two loops.
Yeah.
After you store it, you deploy it one by one and then finish.
Yeah,
Start again.
but so the filling loop happens inside, but the releasing loop happens above you.
Yeah.
So you are just in the loop. You just have to know that you're
And if
next time you're called, you need to hand this character. Next time you're called, you got to hand this character. Yeah.
Interesting.
Yeah, isn't it interesting? It's like it makes sense like when you look at it, but it definitely took. I mean, this is a really low level interaction that people had to work this out. They're like, okay, well, we need a keyboard that we want to enter keys. Like, how is this going to interact with the screen? And you don't want there to be a lot in between hitting this key and the character showing up on the screen. Like, you've all seen a very laggy putting of the character, and that is the most annoying thing ever. So you hit a button and it shows up, but you want to be able to edit too, right?
Space.
So yeah, it took people a little while to come up with this scheme, but it sticks now. This is a good scheme. So putting these ideas together, algorithm pseudocode so far for a buffered getChar keypad might look like that of algorithm 1. And so we're going to walk through algorithm 1. These are the different, so I defined different variable names here. So n is the number of characters in the buffer. Buff is a character array of length bufflen plus 2. P is a pointer that points to the location in the buffer where the next character will be put or taken. And CHG is the character that you got, is the current character from get key. So
wait, so buff is an array of buff length plus 2. So plus 1 would be like the end of file, but what's the second one?
so it's a 2 byte. Well, actually, I think that, the plus 2 is actually because we put in an end of file, but then it always puts a null on the end of every string. So that's the second character. No matter what, I mean, you don't have to do it explicitly. Even if you don't explicitly put it there, it will put at the end of your string a null character. So that's the second one.
So the second one is that the end of file is after or no? You mean?
So end of file. So we're putting explicitly. We're going to put in an end of file. The compiler, I guess it would put a null character at the end of the string. Even if you don't explicitly put it there, it's going to put it there. So that's going to be the next one. But it's weird. There's a certain function. If you ask for the string length, it doesn't give you the null at the end as part of it. But if you ask for the array length, it does give it to you. So it depends on which function you call to ask of the length. But yeah. So there's like all of this. The string itself stops 2 before the end. In our case, if you don't explicitly write an end of file character, then it would end 1 after. Okay, so here's the algorithm. So this is pseudocode, and pseudocode is something that's really useful. And I was talking to Martine about this earlier. I think that it's a good way to take a first pass at writing your program is to just actually write pseudocode, or I mean, maybe even on paper write pseudocode. It helps you structure it, and it helps you see, like, what do I need to do? Does this logic work out? Can I make any improvements on it? So I'm actually giving you the pseudocode that that gets you most of the way on this one, which is kind of nice. I think that this lab's not going to take as long for you guys.
Just convert it to the code.
Yeah, I mean, there is some of you have to add some logic to it, but it's roughly there. But I showed you this in hopes that in your future algorithms that you need to write, that you'll be able to write your own pseudocode for that to help you write the code. So anyway, so this is the pseudocode. So function get char keypad. The logic is, so this if ends down here, this end if. And so this is like, there's no specific syntax. Like, you don't use, some people will use little bits of like C or different programming languages. You see Python a lot in pseudocode. Strictly speaking, you shouldn't see a lot of that show up, but it sneaks in. So if n is 0, then do this stuff. So n, remember, is the number of characters in the buffer. So if n is 0, it means we have an empty buffer, right? So this is the comment I wrote over here. Empty buffer. Then point p to the start of buffer. And while the character that we get is not enter, do this. If n is less than the buffer length, which is to say, if we're not at the end of the buffer, then assign the character that we get to the buffer at p. I didn't put in there explicitly. Somewhere in there, we gotta get we have to get it somehow, right? Get it. So as long as it's not enter, do this. We need an initial one to initialize this. Okay, so then we assign this to the buffer at p, increment p, increment n, print this character that we got to the LCD with put char LCD, and then end if. Okay, so that was this part. And then once we've ended while, which is to say, once we've hit enter, increment n, point p to the start of the buffer, and we go to the next thing. So at this has to happen to see if you need to fill up the buffer. So this whole thing is fill buffer. And so if the buffer was already filled, you don't need to do this step. So this, at the very beginning, we skip this whenever we're releasing characters. This thing's going to get repeatedly called as we release characters from the buffer, but this is going to get skipped most of the time. So if n is greater than 1, which happens after you fill the buffer, that call, it also happens whenever it's called, it's releasing the buffer too. So if n is greater than 1, which is to say that there's more than one character in the buffer, we're going to decrement n and return the character. So we're releasing this back up now to fgets keypad. So this is the part where we're actually releasing it up. So this part here, we're getting it and we're filling the buffer, we're doing all that. In this part, we're actually releasing it up to fgets. And once we've gotten to n equals 1, which is to say we're down to our last character in the buffer, we decrement it to 0, and then we return the end of file character. So that's to signal to fgets keypad, oh,
I'm done.
we're done. That's the end of the buffer. You've reached the end. So that's it. I mean, that's really the logic that we have, which is not too crazy, but it is like, if you don't get that we have a buffer down here that just lives in getChar keypad only, and that there's a buffer up there, and they're separate buffers, and you're buffering inside getChar keypad, and you then have to release one at a time to get written to the other buffer. That's it is a little bit weird at first. So if you're confused, totally cool. But I think that, so at the end, I'm going to draw a little diagram that I think could help. It's going to be with islands and guys in boats. So we'll see if that works. Okay. So now suppose we have ignored this delete thing, this backspace thing so far. So now suppose that the backspace is pressed while characters are being entered. The deleted character is effectively removed from the buffer in the following way. We decrement both the buffer pointer and the counter n. The deleted character is removed from the display by moving the cursor left one space, which is done by sending an escape sequence B to it, printing a space, which we can do, and moving the cursor left one space again. So we back up, and then we go over it with a space, and then we back up again. Which is weird, but also exactly how your computer deletes something. So.
Everything we do, we still have the memory. We can track what we delete in the word file. We just click track, and everything we delete is still there.
Yeah.
We can accept or not accept it.
Yeah. So, great. What should happen if backspace is pressed before any characters have been entered? Or say n is equal to 0. This is a question for you guys. Modify the pseudocode above and your program to include this delete functionality. So this pseudocode does not include that's delete functionality. So you do have to add that. It's not a lot, but you do have to add the delete functionality to it. So this is, filling the buffer, and then you're releasing the buffer.
It's supposed to be in that fill buffer.
Right.
That delete.
So you're thinking that this is where, somewhere in here,
Yes.
you should have the delete.
Yes.
Yeah, that's correct.
So if n equals 0 and the delete button is pressed, right, couldn't we just ignore the delete button?
Yeah, so but you have to have a case for that, because what could happen is if you treat it the same, you could have the keypad throw an error, or not the keypad, but the LCD throw an error, because you might ask it to back up the cursor, one when you're at the beginning of the beginning of the line, and I think it throws an error code at that point. So you have to handle what they do if they hit backspace when they're at the beginning. Also, if you don't, sometimes if you prompted it, then you have a prompt printed out, and then if they hit backspace, you don't want them to be able to delete your prompt. So you want to stop that, but they could if you keep using the same handling of delete, and you give them a prompt, and you just say, oh, if it's delete, then move the character left, overwrite with space, and move it left again, then you'll just be able to delete the whole prompt, which is not something you want, probably. You want to keep those users in line. And you always think, when you design an interface for a user, they will. They'll do everything they could. I mean, and this is also, vulnerabilities are exposed with this kind of thing too. Like, you don't expect, what was that one that was really bad last year? Where some websites were exposing their server-side data by you could what were they doing? They were like you could enter in you could ask for from a box like an enter on the website. You enter something. You could ask for characters to be returned from memory beyond the place where the data for that was located. So what they were doing is just like people were just sending requests to just like read data for way past that memory value, and so they were like exposing passwords and stuff. So yeah, terrible. Should never happen. But also, when you write it, you don't think that the user is going to be malicious when they're entering stuff, but like they can be malicious. I mean, for an embedded computing application, like you don't expect that usually, but embedded computing applications that are like connected to the internet are super vulnerable. All of those like Internet of Things devices there are websites of just like people's nanny cams just on live feed because they're not very secure. So yeah, it's pretty bad.
Yeah. There is also a case of like a white-hat hacker. They try to hack a big institution to know that how strong their firewall is or how strong their security is.
Some people do it for fun.
Visa is the most the target always because where the money is.
Yeah. Yeah, they some people hack for fun, some people hack for the money.
Mm-hmm.
I'm not a hacker, but I've always wanted to be a hacker. Yeah. I would do it for the glory.
Yeah.
That's why I would do that. No, it just always sounded fun to me. Okay, so where were we? We were talking about, so you guys have to modify this to do the delete. And then writing the main function, just like last week, you have to write a main function that tests it. In this case, it should collect at least 2 separate strings using fgetCkeypad, which calls fgets, or getCharKeypad. Some background. To accomplish its task, getCharKeypad must read characters from the keypad. The getKey function returns a single key code for each keystroke. This prototype is as follows. So a call to getKey, so it doesn't take any arguments, it returns a character. A call to getKey might be key equals getKey.
We use this code in order to ask the user to enter to type on this. So
not the prompt per se, but this is actually to get each key that they type in. So your key that comes in, the lowest level handler of each key press is getKey. And it returns one character. There's no buffering. It's just one character per keystroke on demand, just bam, bam, bam. So we'll talk more about how to write getKey. We're going to write getKey next week. But for this week, it's just going to return to us a character at a time.
So we use this one also.
Yeah. So we're going to use getKey this week, but next week we'll write it. Corresponding to each of the 16 keys of the keypad, the key code is shown in table B.1. The symbols are defined, which is to say there's a macro for them, in the header file me477.h. So table B1, the left table, shows you the key, the decimal code that comes in, and then the symbol that represents it. So for the backspace, enter, up, and down, these symbols, if you write these symbols anywhere in your code, we'll talk more about macros, but that's equivalent to writing an 8 somewhere, or ent is equivalent to writing a 10 somewhere. And actually, before the compiler even sees it, during the pre-processing of your source code, it's going to get turned into the decimal code. Like when you write a macro, this never gets defined as a symbol or anything like that. It's not a variable in your C program. Every instance of it in your program gets overwritten by the number, which is really nice in the sense because you get freedom to it lets you write your code with symbols, but which makes it easier to write, but it doesn't require that there's memory associated with a variable that's named that. So it lets you write more compact programs. So they just put the literal in instead of putting in a variable. So we'll talk more about those at the end, but these are the symbols that are defined in the ME477 header. The decimal codes are what you need to use for minus, period, and 0 through 9. And by the way, our keypad has a blank where didn't get a sticker with the decimal point. So there's a blank which means decimal in our keypad. So that's 46 decimal code.
I still have one question about this decimal. So when we assign, first of all, it is a string variable. So we write, this is the string, and it's stored in decimal in the memory. Is that correct?
Yeah. So remember each character is defined by an ASCII code, right? So the ASCII codes are just integers. So they're just integers that are being interpreted. So you could interpret it as an integer, you could interpret it as an ASCII code. So these are the codes that are returned from get key corresponding to each key that you press. So when you press one of the numerical ones, it returns one of those codes. So sometimes it gets a little tricky because you can look at it as a character or you can look at it as an int.
Yes.
But we can sort of go back and forth. It's just fine most of the time. Where you run into some trouble is that there are some ASCII character. Well, there are some ints that are not ASCII codes, and so then you have to define it as an int. But these ones are all ASCII codes that we can read, the decimal codes.
But for example, if I type 48, it is the string, right, from the keypad.
Yeah.
So this is not a value number.
So it would do a 4, which would be, 48, it's like 52 or whatever. 53.
Yes.
It would return a 53, and then 8 would be whatever, add that. 56. Those are the codes that would come back. So we would have to interpret those. So we have to interpret a 48 to be a 0 and a 57 to be a 9. We have to interpret that. So that's if you say it's a char, then it knows you're going to interpret it as ASCII. If you don't, if you just say it's an int, then it says, well, it's a number. Who knows what it represents? It might represent an ASCII character. It might represent something else. So, yeah. Okay. Notice we're getting a char though back from getkey. So we're saying, it's okay. It's an ASCII character that comes back. Yes. In addition to getting keys, getchar keypad must be able to print characters minus, decimal, and decimal digits to the LCD screen. The ME477 library function putchar LCD should be used. Its prototype is as follows. So it returns an int to you. The putchar LCD, you give it an int C, an int code for that C, and that is both the input parameter and the return value of the character to be sent to the display. So these are you give it C, it returns C.
So in this case, all these interfaces are defined already. You don't have to use anything. You just press the button.
Yeah. So we'll write this one next week too. So putchar LCD will be written next week. For now, what you do is you hand it the character, and it will print it to the screen. So the following are examples of calls. So you could do putchar LCD and then give it the character M. You just did a character literal by putting it in this quotes, right? So the character literal, and it puts it to put char LCD. Also, so the reason why you're like, well, why would put char LCD return the same character that you gave it as argument? And the reason is it's kind of convenient to be able to write this. Like, you could define your character and put it to the LCD at the same time. It's all about compactness.
What's the difference between quotation marks and apostrophes?
They can both be used to define a character or string literal, but I am fuzzy on when and if there are some cases where there's differences. It's language dependent, and I don't know about with C. I can't remember which one. I always have to look these things up because every language is different. It is common in some languages to have one of them be escapable in the sense that you can insert something in it. So you could have like a variable that you insert into the middle of a string. Typically, I don't know if this is true with C, I can't remember right now, but double quotes typically lets you do that, and single quotes doesn't let you insert anything in it. It is just reads it literally how you write it. In a double quotes, sometimes you can insert different variables into it that it'll read as variables. I can't remember right now. Let's see. It's just one of those things that you guys, when you write programs, and this is true of people up to like mid-level, reasonably good software developers that I know, constantly looking up syntax for the language that they're working on. Like Googling stuff, and you're like, oh, this person's like a genius hacker, but they don't remember the syntax always either. Depends. Certain languages people get crazy good and they don't have to look up stuff, and those people are at another level. So they also get paid at another level too, typically. Software developers who are like that. But then you don't have to assign what char LCD returns either. So you can just hand it the string or the character, and then it'll just print it and return.
So when you write like this, it's next line.
So this would be, this is the new line character. So puts the cursor at the start of line 2. Yeah.
But if you put 2 quotes, it will read the same thing.
Yeah, it will read the same thing. I don't remember. There might be some cases where 2 quotes can be interpreted differently, but 2 quotes should be fine for this. Yeah.
I put the 2 quotes.
So, so it prints, So the put char LCD function uses the same escape sequences as shown in table B1 as printf LCD, which we wrote in lab exercise 1. So this is the same table that we saw before, but I just included it here for reference. And then I think I'll split off and we'll do the guidance lecture separately. So I'll close this one. We'll take a break. If there are any questions on the above stuff, otherwise we'll come back and continue.